Hi, we're at the home of Dave Leeper, one of the engineers in the Classroom group, and Dave decided a couple of years ago to take advantage of all that great energy from the sun that we've been talking about and the photovoltaic effect, which converts sunlight directly into electricity. And so what Dave has done is, in Dave's house, he's put these solar panels up on his roof. We're going to go take a little bit of a look at those panels, and we're going to also then take a look at some of the electronics behind all of this and how it actually works. Hi, we're down at the side of Dave's house. First though, remember how solar panels work. These panels are semiconductors that have been sort of modified, or what we say doped, with certain properties, so that when the photons actually hit these panels, electrons are released. And that's actually what forms the flow of electricity through these panels. These panels produce direct current, DC, that we've talked about, and they're producing 200 volts of DC power. So the first thing we have to do is we have to match the power that's used in the house, which is 110 volts AC. That's what this box does. This is called an inverter, and it actually converts the DC power into AC power. But the other thing it has to do is it has to integrate with the power that's coming off the power grid from the electric company. So the AC power, which alternates 60 times a second, this has to generate AC power that's exactly synchronized with the power coming from the grid. There are various functions that you can look at in this inverter that tells you how much power is being produced and at what rate. And there's a meter here that actually tells you how much total power. So in Dave's house, he's produced over 16,928 kilowatt hours of electric power, which is a whole lot. Right now though, it's just about noontime, and the sun is nice and high and generating lots and lots of power, actually generating more power than Dave is actually using in his house. So what's happening is we're taking that excess power that he's not using, and we're actually feeding that back into the power grid. The electric company is actually buying the power back from Dave that he's not using, and it's now being used in his neighbors' houses. So an extremely efficient system that even when he generates more, he can still get that power used somewhere else in the system. Because we know the biggest problem with electric power is that it's very hard to store. Easy to generate, but has to be used pretty much at the same instant that you generate it. Unlike other fuels like coal or nuclear, where you actually save the energy, you can't really save the energy of electricity. But given there are other places that can use what he's not using, it all gets used up efficiently, and we take advantage of the power of the sun.